Hey everyone, today we're going to do another precedent study, or another kind of parametric precedent. That's what I called it. We're going to do another one of those. Today it'll be on a, sorry, my throat seems to always be hurting. Or not hurting, but I always have to clear it when I'm recording. It's kind of strange, but anyways, today we're going to get into another one, and it's going to be a parametric brick wall. I follow this page on Instagram. You guys should as well. They post some really cool content in terms of parametric design, and it's very interesting. A lot of those designs go over my head. It probably takes months for them to design, but oh, sorry about that if you heard that. Teams take a lot of design, but anyways, so yeah, I follow them on Instagram as well. But anyways, so you have we're going to create this parametric brick wall. I know these aren't bricks exactly. They did this in the graduate school of Harvard, so it's actually a very simple script, but it's also kind of it's different. So the way we're going to approach this is we're going to create a surface first that would guide these bricks along. So we're going to create, the easiest way to create a surface is by a loft. So we're going to create this curve that reaches all the way around here, and then this straight curve here, and then we're just going to loft the two. That will create the surface. And once we do that, we can start to actually mess with where the bricks are and how they are arranged in the script. So anyways, that's it for this. I may keep this up for reference, or I may pull it back up for reference, so I minimize it this time, just to make sure. Alright, we are good. So the way to make those curves, and the way to make that kind of curve right here, that curve that we saw was a sine curve, or what I identify as a sine curve, what I identified it as a sine curve. So let's get started. So the way I would do it is usually you start messing with points, and then once you get to mess with the points, you can create, with those points, create a curve, and then with the curve, create the surface. So that's usually that's the order I'm going to work with today. So we're going to do construct. Construct point. All right, cool. And so now we have that point in the 0, 0, 0 origin, or at the origin. So sorry if I keep moving this around. I kind of fiddle when I use grasshoppers. So we have the x, y, z coordinate right here. So we have this construct point. What I'm thinking of, so what we have done in the past is once we have a point, we can do a move, and then do this, and then let's say we wanted to move along the x-axis, we would do x, and then we would do a series, right? We would do all these steps, the move in the unit x direction with series. There is another way you can do this. Another way to do it is to actually, instead of doing all this, it saves a little bit of room. It really doesn't. It's not. I don't do this that often, but for the sake of this, I want to show you guys something different, and maybe that'll help you guys out. Personally, I always do this and then the move, because it helps other people read, like, okay, construct point, then we moved it. But another way to do it is you can actually just, instead of these two here, you can actually just plug in series into x, and it'll do the exact same thing. And I think that's the way we're going to approach it today. We're going to do it like this. And so we move these across the x, and I'm going to set some values. So I'm going to set these at the count of 12 right now, and this will be important later. Alright, and then we have the y and then the z coordinate. So the z, we're going to remain at 0, 0, or at locally defined at 0, like it says here, and then it has the y value. So the y value is what will change it from just this straight kind of articulation of points versus this curve. I am referencing the photo, so I definitely will keep it up for future tutorials. So the way we're going to do this is we're going to use a graph mapper. And a graph mapper is confusing at first, but once you get the hang of it, it's not too bad. Even for me, I still get a little confused about it, so if you get confused about it, don't worry. We're also going to put a multiplication here, and the reason I'm putting a multiplication is this will determine the height, this will determine the amplitude of the sine curve. Okay, there we go. I want to make sure I get that correct, so you guys understood that. So we're going to plug the y into the multiplication, and then this will be the amplitude of the sine curve. Right now the graph is showing nothing because we haven't defined what graph we wanted. Right now it's just a blank graph that represents absolutely nothing. It's literally like a blank note almost. It actually has like no value at all. See, it says empty graph mapper object. And then now we're going to do a range. And this range will determine the how much it will affect the points, if that makes sense. So this range, what I mean by how much it will affect the points, it's basically we're saying, all right, since we have 12 points, we want to affect all 12 points, correct? So we want to do that. Versus if we want to only affect 6 points, we would only do the 6 points here. So for steps, you would say 6 versus, or 5, sorry, instead. And there's a reason why it's 5. 5 steps instead of 11 steps here. So now let's get into why I said, oh, I guess it does have some geometry. But so basically this range component determines the amount of effect, or like the effect we'll have. So for example, if I say, let's do that 5 example we had real quick. We do steps of 5. Right now it's reading as a linear slope right now. That's what the graph mapper is reading. As you can see, it only affects 1, 2, 3, 4, 5. We can even, let's say, count this one, 6 points. It's only affecting those, and then the rest are straight, as you can see. Because right now the range is saying, okay, only affect those 6 points, and then the rest ignore. So that's what it's saying right now. So let's say we bumped this to 11 right now, and right now it's affecting all of those. And right now the steps, the reason why it was almost complete right here is because it was defaulted at 10. So let's get, so the way to do this and kind of automate it instead of changing it constantly, let me move this to the side a little bit, instead of constantly having to do 12 minus 1, and that's where it comes from. That's why I said 11 and 5 if I wanted 6 points articulated. So if we say this 12 right here, we have 12 points, we want to affect all 12 points, we're going to say 11 steps. And here's why. If you look up the tree counting principle or any of these, you always know that if you have a series of points, let's say 12 that we have right now, it's always going to be minus 1. Because this steps right here in the range, it's asking for the spacing. How many spaces are in between the points? Or how many spaces are in between all 12 of these points? And they're always going to be minus 1. So if you have 100 points, it's going to be 99 steps. If you have 325 points, it's going to be 324 steps. It's just minus 1 every time. So we can even count it. So let's turn that number down to like, oh, I guess we have a lot of points now. Why is it doing that? Oh yeah, because I have the graph map on. But let's just say 11 right now. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're always going to have minus 1 steps. So we're going to do a subtraction component because we want to subtract. We want to always subtract it by 1. So 11 minus 1, and if you look at the result, it'll be 10. That's exactly what we want, and it'll always affect that amount. If you want to use a number slider, I usually just like to use number sliders for everything if it's in terms of numeric values. But you can do integer here, and then you can say, if the integer isn't important, you can say, you can label this 1, but that won't make it 1. You still have to set the integer. So right now it's just labeled as 1. It's labeled as 1 and not set to 1. So you can go to set integer and then say 1, and then commit changes, and then just do that. So yeah, it's the same thing. It's just a little bit less clunky in my opinion. There's like a lot less, because number slider is longer, so it looks a little bit, the script looks neater. Because you're only doing 1 and you want it constantly at once, so you don't really need to change it. Usually you use a number slider for a parametric kind of, or a kind of series or iterations. You just kind of change it if you want more or less. So right now I'm at 44, so I'm going to turn it down. Alright, So let's get to that curve that we're trying to get. Right now we just have this slope, which does nothing for us. And see, this is the amplitude, so it's changing the highest part and the lowest part. So right now we can change that. So let's go to the graph types. So we can look at, these are all a bunch of graph types we have right here. We can do parabola, we can change that. We can start to do something like this. We can also do graph types and look at the sine function, which we were originally going to do. And we can start to actually manipulate this curve to look something like that, like maybe like that. Let's see what it has. 1, 2. So 2 amplitudes here. So I think that looks about right. Then we can change the kind of depth of it. And then if we want to add more points, we can for the term in the sake of accuracy. So I just add a little bit more points, 23. And the number doesn't mean anything. It's just the amount I want there. Excuse me, I'm sorry. So we have these points, and what we're going to do now is we're going to now create a curve that will go through these points. Now there's 2 ways to do this. You can do either a NURB curve. I don't know which one. I think it's this one. Yep, you can do this one, or you can do an interpolate curve. This one does it not exactly. As you can see, the NURB curve is basically kind of an influenced curve. It's basically a curve that is influenced through these points. So as you can see, they don't cross it, but the points influence how the curve kind of is portrayed. So as you can see, it's definitely like it's influenced by it, but it's definitely not like it's anchored to it. So like for example, if I go on Rhino, it's like this one, which is just curve. As you can see, it does. This point right here does actually influence like the curvature of it. If I just do that. Or I usually don't use this one. I usually just, if I have points, I usually want them exactly where they want to be, or exactly where I want them. So I use this interpolate curve, or it's just called interpolate. It just creates this interpolated curve through a set of points. Plug in the vertices just like the NURB curve, and you get this. You can see it's not just influence, it intersects through the points. So awesome, we have that. So awesome, we have that curve. So we have that curve, and now we just need the line here. So what we can do is we can just do another construct point. So we're going to make a second construct point, and we're going to create a whole separate curve that's going to be just a straight line. And it's really easy because all we need to do is basically just do a series within the x direction, and we're going to take the exact count we have in here because we want it to be the exact distance. And then what we're going to do is do a move in the z direction. And then we can go in perspective view and see, and we can move in the z direction, let's say about 15. I just kind of plugged in some numbers, a little higher. Alright, and then let's turn this one off because it's confusing. And now we have this. So to create a curve, you also can do an interpolate curve as well, or you could do a polyline here. Doesn't matter, these both work the same. Like, they actually make no difference. I think one reads differently in terms of list, but I'm not too sure. This one just reads one linear curve. Well, this one, no, same thing. So they literally did the same thing. Alright. So I'm just going to do a polyline because I can find it easier. Polyline, and now we have that. So now once we have these two curves right here, 1, 2, we can now do a loft. Let's say this bottom curve, and then the top curve, and then yeah. And if something doesn't work with you when you loft something, there is something called loft options, just like in Rhino. You just plug this in, and then you read them, and it says you want it closed. You say it says false right now. This one says false. This one also says 0, 0. Refit within the accuracy of 0.0, so only a tenth. and then the type of loft you want. And so it has a bunch of, if it says false, if you read any command, this is for any node. If you read something that says false, it means right now it's set at 0. That's what it means. But if you set to 1, that means true. And it can't be closed, by the way, because it's 2 lines. You can't close 2 line curve. It doesn't make sense. So false is 0, then 1 is true. That's how everything in Grasshopper works in terms of the false true kind of components of the program. At least from what I know of, that it's been working for me so far. So usually if you just hover over these, it'll tell you what you need. It'll tell you like, oh, this one's locally defined at 3, this one is locally defined at a value of false, so things like that. So now we have our lofted surface. So we did step 1, we have the surface. So now we're going to actually try to get those bricks on this surface. So we're going to do, in order to do that, we're going to try to create some kind of order here, because you see that bricks are pretty linearly ordered in terms of like how they are, how they are kind of stacked. They do have, in terms of a horizontal, if you look horizontally, the bricks are very linear. They kind of have like if the brick was 2 inches tall, it'd be 2 inches, 2 inches, 2 inches. It doesn't deviate. So what I mean by that is we can actually start to use a contour. We can actually contour this shape. So it asks for a point, direction, and distance. So I'm going to set my distance at 1 to make things easy, and direction in the Z direction. And it's already defaulted at the Z direction for some reason, but I am going to define it further by just putting the node in there. So if anyone else looks at the script, they can understand it. So the reason why this is more confusing, than instead of doing move, is because when other people are trying to read your script, it's a little harder, or if they don't know as much Grasshopper knowledge, it's hard for them to understand the script. And that's just my opinion, at least. So now we have this, and what we're going to do is we're going to make, if we try to do that, we won't have the bricks right now are actually going along with the curve. They're not just they're not in an axis, they're actually flowing with the curve, as you can see right here. So we want to do the same thing there. So we're going to do something called a horizontal frames. And we're going to plug in the curve, and it'll create basically a bunch of horizontal frames. It basically creates a bunch of axes for the curve. So as you can see, you can vaguely see this frame going along with that curve with each of those points. So let's see how many points I have. So I have basically a horizontal frame is basically a divide curve component, but with frames. That's literally it. And I think that's what makes it nice. So I'm going to do the exact count of whatever these are. So these are 23. I'm going to make it 23 as well. So 23. Awesome. So we're going to turn these off because it doesn't help us out. So we just know that the frames are there. And then we're going to do so we're going to create a box now. Or we're going to create the actual bricks now. So we're going to do center box. So that's for the base, X, Y, and Z. So click base, and then we just get a bunch of bricks. Right? But these are, man, I don't know why it's doing this. Sorry about that, guys. I don't know why it's not letting me zoom. So I'm going to actually, the way I fix this, I just do that. Zoom select, and then zoom out a little bit. And I should fix it. Alright, so as you can see, it's kind of messy. So I'm going to make the units very small on all of them. CBV, like that. I just want to be able to see them. Okay, so we do have our bricks now. They're very small. I just kind of made them like this on purpose. They're not going to stay this dimension. I just put that so we can see. And so the z-axis is this way, as we know, is up, or it's up. Okay, so anyways, it's up. So we can actually do some math and parametrically do this if we want to create iterations. So we know that this distance is 1, and we know that the dimensions will go halfway here and halfway here. So we can actually do a division and do this. So not that. This divided by 2. Plug this in. Plug this in. And then now, as you can see, they touch right here. They don't actually intersect. So if we do parametrically change this, it will not kind of cross and do some funky stuff. So you have the x, y. So let's figure out what we need to do. So we need to now create in the y direction. No, the y direction doesn't really matter that much. We can change the y to anything. So the y is an isolated variable. We just need the x. We just need the x to be. Sorry about that. I got a call. It's kind of weird. We just need the x to be in a direction here. So let's do that real quickly. Let's make this. It's the division, so we can just do a division as well here. I think we can math this out or just play around with the slider. That's the best way I figured it out. So that's this, or it's this divided by 23. Alright, let's just say 23 here, because I know that's the count. This 1 divided by 23. Okay, that doesn't do it. Alright. I didn't think that was going to work. I don't know why I thought that was going to work. 23. So we can just actually mess around with the number sliders. That's what I'm probably going to try to do. So let's try with 2. Alright, 1. That's 0. Let's make this range 1. The rational. And then we can actually mess with how thin these are. These don't look like bricks yet, but we can actually start to beef them up in the y direction. Okay, so these don't look much like bricks. So I'm going to actually lower the. Maybe I should make the count independent from that. Make the count independent. Actually make it a little bit less, so we can actually we have more wiggle room in terms of this dimension, so it looks a little bit more like bricks. Rational, and then something like that. Alright, cool. So now we have this, but it doesn't look like bricks at all, right? It just looks like rows of stuff, which doesn't help us out at all. I can delete this. So let's do so if you see, a brick is basically a pattern. It's like, it's inverted, right? There's 1, 2, and then there's 1 here. So it's kind of this patterning system of bricks, right? It's 1 brick here, and then 2 holding this 1 brick up, and it's constantly like that. Just basically a normal brick pattern. But right now it doesn't look like that. So I'm actually going to hide this. We're going to do a col pattern. You can also do a col nth, but I don't like doing those. Because I mean, I know how to use it, I just like to be able to manipulate the way I want it to. And that you can do col nth, but I like col pattern also works. So I know that it's going to be a 1, 0 pattern, and I'm going to uncheck multi-line data, go to col pattern, and then go to list, and now it looks like this. And you're like, all right, that didn't really solve anything. What are you doing? And I'm just like, yep, it didn't solve anything. So right now we're going to find something needs to be, I'm missing something very important here. Because right now the count is not, where is it? Horizontal frame. This needs to be 24. Oh, gotcha. Alright, so I'm actually going to keep this an odd number just for this, just to show you why easy way to mess up. That's an odd number. I also messed up here because I forgot to, and I'm going to explain it. Each one of these are in groups, or not groups, they are in different branches. So this is branch 0, branch 1, branch 2, yada yada yada. So basically it's reading right now like 500 boxes. It's 504 boxes. So, alright, I'm going to keep this up just for you guys. Sorry. So actually, there we go. So right now that's what's reading. So the way to fix this is you want this all to read under one list. And you're wondering, how do you do that? Easy way to do it is to flatten this. You can do a flatten and plug the tree in and do this, and that will work. Or you can do a this and do flatten here, or you can do flatten here. Doesn't really matter, and it gets the job done. And the reason why I start playing around with this, let's keep that at 23. And you're like, dude, nothing has changed. I mean, what's going on, right? Like, let's say you kept it at 23 like I originally had it. You're like, something's not right. It's not adding up. I mean, I did what you did. I flattened it. It's not working. Well, if you think about the cull pattern is working. It's reading, but it's reading differently. It's reading as a 1, 0, 1, 0, 1. So right now it's reading 1, 0, 1 because it's an odd number of stuff. If we have an even number, it'll read 1, 0, 1, and it'll actually create this bit checkered pattern, or this brick pattern now. So yeah, now we have that brick wall. We can actually bake the geometry to see if we did anything. We got it right, and let's see. I'm going to move it here. Let's see. And it looks like we got it pretty good. Right now it's a little small, but overall, and this one is a lot more severe than mine, but I think it looks pretty good for how it is. And you can mess around with the graph mapper and actually do different types of geometry. But yeah, this is basically a tutorial on the parametric brick wall. It's very simple script, and I hope it helped you guys out. This is just basically another practice in terms of list manipulation again, and just logically thinking it through. So yeah, guys, thank you guys for watching. Hope you guys have a great day. Bye.